you now get to see all of my options off to the side. So just ignore that, but it has to do that. Okay, so here's our problem for today. So your problem on your homework is going to look very similar to this. This is your problem. I feel like we've done something like this before, where we're in a vehicle, or in this case, we're two planes leaving an airport at the same time, traveling in opposite directions. You may have heard this with the train problem, where two trains leave at the same time, go in opposite directions. So there's always different variations of this style of problem. So we want to kind of talk about how do we describe this motion, how do we set up these equations, and how do we find the speed of each plane. Okay, so kind of reading this question further, the one plane is flying 75 miles faster than the other plane. That's all I know. I don't know the speeds, but I know one plane is going 75 miles per hour faster than the other. And then I also know that after 2 hours, they are 2,050 miles apart. So I want to know at what speed was each plane flying. And so we have a lot of things going on here. And I gave you the most filled out version of the notes as possible, just to kind of help us out here. So the first thing that we need to do is define our variables, just like how we did yesterday, right? So yesterday we said, well, what do I not know? That's going to be X, that's going to be Y. So we already have this written down. X is going to be the speed of plane 1. Y is going to be the speed of plane 2. And so when you get to the homework, you're going to be responsible for figuring out what is my X, what is my Y, okay? Because I don't know either speed. And so we can also kind of imagine this. We don't need to draw a super crazy sketch like on the homework. You don't have to give me as much detail as this, but just something of kind of sketch out or write out the information that you have. So I know plane 1 is going one way. We can say it's going to the left. Plane 2 is going to the right. And so in total between them, right, they are 2,050 miles apart. So this distance between my two planes here from end to end is 2,050. And I also know the total time. I know that the total time between them is 2 hours, okay? And so at this point, it is also important to just say which plane is going to be the faster plane, okay? So we're going to say, it doesn't matter. I'm just going to say plane 1 is the 75 miles faster than plane 2, okay? So we're going to call plane 1, right? That's going to go 75 miles faster. You can go the other way. You can make plane 2 go 75 miles faster. You just have to pick. So we're going to say plane 1 is going to be the faster plane. Plane 2 is going to be the slower plane. So that means plane 2 speed is 75 miles per hour slower than plane 1, okay? So that's kind of where we're starting. So we have a good visual of what's happening. We know we've gone a distance away from each other over 2 hours. One's going faster than the other. Okay, so this is now kind of a newer formula that we haven't talked about yet, which is why we need to go over this. So this is pulling in maybe some knowledge from a physics or a chemistry class. The distance formula. So distance formula, this is universally accepted. This can be used in all parts of math and science. Distance is equal to rate times time. Okay, so that's what the R stands for, rate times time, T. So rate is just another way to describe speed, all right? How fast we're moving. So however your distance is going to be, however fast you're going times the time. That's how far you travel, right? Makes sense. If I'm going 75 miles an hour and I am traveling for 3 hours, I would do 75 times 3. That's how long I've traveled, right? So that just makes sense in the context of how we know distance works, right? So that's our formula. So if I want to describe the distance for plane 1, I can say, well, I don't know the speed, right? That's what I'm trying to figure out. I don't know the speed of plane 1. So plane 1, right, the speed or the rate we said was x up there at the beginning. So I can say this is the same thing as x times time. So we know that the time has gone by 2 hours, right? So I'm given a time of 2 hours. So x times 2, but that looks weird, right? So we typically write this as d equals d of plane 1, we can say, is 2x. Right? So, but I wrote it in the right order. So that way you could see that my rate is x. I don't know what that is. So we're just saying that is the speed of plane 1. I don't know. The time is 2 hours later. So that would be how far that plane travels. Plane 1 will travel 2 times x, depending on however fast that plane is going. I can do the same thing for plane 2. Plane 2's rate we said was y, because I don't know what that is yet, times again the 2 hours, but that looks weird, so let's write that in the more correct way so we can say distance of plane 2 is going to be 2y. And so that still doesn't really help me, right? I still have 2 variables, so now we can kind of put all this together. I do know some other important information. I know my total distance. I know that the total distance between that we traveled is 2,050 miles, okay? According to my problem says, right? So we're 2,050 miles apart. So we start at distance 0 in the middle. I now know that between them we traveled 2,050 miles. One is obviously traveling more than another, but in total, we have a total distance of 2,050. So here's where I can set up that final equation. I can say 2,050, that distance total, is going to be equal to the distance that my plane 1 travels, which we said is 2x, plus the distance my plane 2 travels, which is 2y. Okay? So again, hopefully you can kind of see this is already worked out for us with kind of the labels of all I'm doing is just substituting each part in, right? I know my total distance is 2050. D plane 1 we said is 2x. Distance plane 2 is 2y, right? So that's going to be my answer, right? I don't know what the speeds are yet, but that's a good way to describe that distance, okay? So that's kind of the first thing that you'll need to do. But that's still just one equation and I have 2 variables. So I know there's something else that I need to come up with to help me figure out the speeds. And I can look at the fact that plane 1, so again, we described that plane 1 is flying 75 miles faster than plane 2. That's what I said. You can do it the other way. You can say plane 2 is traveling faster than plane 1. It doesn't matter. You just have to pick which one is going to be the faster plane. So we're saying plane 1 is going to be faster. Okay? So what I like to do is I'll kind of explain this way down here, but then I'll also explain it a second way because sometimes people get confused with the first way. So we can say always, this is kind of, again, another universal mathematical kind of statement. This will be useful if you do take physics or you take a chemistry class. The difference in speed is going to be x minus y, okay? Always. So that's just kind of something that we can just universally accept. The difference in speed is going to be x minus y because I'm saying x is the faster plane, right? So because x is the faster plane, plane 1, I'm going to say x minus y. Now, if you said plane 2 is faster, you would want y minus x. That one's the faster one, so that one's going to be the bigger number. So we can say my difference in speed is 75 miles per hour equals x minus y. But I also want to kind of talk about this another way. If you're like, okay, I'm not really going to remember that, or that doesn't make a lot of sense to me. Another option is to turn this sentence into an equation. Because a lot of people can understand that sentence. We say plane 1 is flying 75 miles faster than plane 2. So plane 1, that is the x variable, right? So down there where it says x equals speed of plane 1, y is speed of plane 2, I'm just going to turn that first sentence into an equation. Plane 1 speed, okay? So that's my x is. Remember, is where we always put that equal sign. Whenever you see the word is, so we're going to say plane 1 is. So that speed is 75 miles faster than plane 2. So I see that number 75. So 75 plus my speed of plane 2, which we already described as y. Okay? Because I don't know what they are. But let's think about this. Let's say, I don't know. We can say 1 speed is going to be 30, right? Then you can just kind of plug that in and you kind of work through that equation here, okay? So that's another way to think about it. And if you're wondering, how are these the same? Well, you could move this one over, right? If this one, when you're trying to solve for x, you would add y to both sides, right? So 75 plus y equals x. So you can do 2 ways. You can have that equation up there if you feel like turning the sentence is easier for you, or you can just memorize that it's always going to be your difference of speed, so whatever difference they have in between them is x minus y, where x is that faster plane, okay? So now I can go ahead and solve. So at this point, I have two equations, right? And so there's stars next to both of those equations. And so the first one, we have the 2, 0, 5, 0 equals 2x plus 2y, right? That was my distance one. That was my distance, okay? And then my other equation was relating the speeds. So that way I still have two equations. So I can write either one. So I'm just going to write it with the one that has the star next to it. So that's 75 equals x minus y. And so I like to, again, stack them on top of each other. So maybe that will help me figure out a little bit easier how I can solve. Okay, so because I'm using that equation, the 75 equals x minus y, it may be easier to eliminate here. But off to the side, I'm going to show you the other option. If you chose to write your equation how we did up at the top by turning that sentence into an equation, if that makes more sense to you, then you may want to use substitution. Okay, so whichever option, however you were writing them, it's up to you. I'm going to go ahead and show elimination because yesterday we did a lot of substitution, so I want to make sure we're good with elimination as well. So I'm going to solve this first equation this first system by elimination. All right? So however you want to think about it, again, I know some of these word problems get kind of weird, so you can either just memorize difference of speed is x minus y, or turn your sentence into an equation. That's the one part that always throws everyone off every year. So I'm giving you two ways to think about it. Okay, so if I want to solve this first system here it doesn't matter. We need both the variables. I think the easiest one here is to multiply that equation by 2, the bottom one, so that way my y's will cancel, right? I have a minus y there, so if I multiply by 2, it becomes a negative 2y. So we have 2050 equals 2x plus 2y, and then I have 150 equals 2x minus 2y. And so then when I add down, I get 2200 equals 4x. My y's cancel. And so then when I divide by 4 on both sides, I get x equals 550. Okay, 550. So we'll kind of come back to what that means in a second. Let's go ahead and work on solving that second variable, and then we'll kind of take a step back and see what does that mean? What did I just solve? Okay, so then I can plug that back into either equation. I would definitely pick the bottom one because there are no numbers in front of the x or the y. That's going to be the easier one to solve for. So if I plug that back in, I have 75 equals x, which is 550, minus y. So when I subtract 550 from both sides, we get negative 475 equals negative y. Therefore, positive y is positive 475. Okay, so now let's take a look at what we just did. We just found x and y, which we have been saying all along are the speeds of the planes, okay? And so I could say, kind of in the final conclusion here, we can say that plane 1 speed is 550 miles per hour. And then we can say plane 2 speed is 475 miles per hour. And we can double check ourselves. Plane 1 is the faster plane. That's what we said, right? 550 is faster than 475. There's also a difference of 75, right? If I do 475 plus 75, I get to 550. So I know I did this one correctly. I kind of meet all my requirements. So maybe now that we get our answer, that also kind of helps us look back at how we set up those equations, right? So maybe that helps you with, if you weren't sure with what x equals 75 plus y, we're saying plane 1 is 75 miles faster than y. So if I know y is 475, I add 75 to that, that gives me plane 1 speed. If you don't like that way of thinking, use this little formula here. Difference of speed is x minus y. I think everyone last year did a pretty good job with the distance equals rate times time. I think we did pretty good with that. So I like these notes. They're very detailed. Your homework, though, is going to be a little bit more, if you look at it, there's not as much there. You still have kind of all the questions and the breakdown, but you will want to look back at your notes, especially for maybe your distance formula, for that difference in speed formula, things like that, okay? So the homework, it's just one question, pretty short. Today was just a pretty short lesson overall, so that way we have some time to catch up from yesterday, since so many of us were gone.